G'day everyone and welcome to today's video on stem and leaf plots, part of a year 8 series on maths. I'm recording lots of energy. It's a Sunday morning here, the weather is cool and life is good. And if you are wondering what on earth this is all about, well actually it's a video on stem and leaf plots. You're going to know what a stem and leaf plot is, how to draw one, how to read one, and how to do all sorts of exciting things like mean, median, and mode and range if you can. So before I continue, hi guys, I'm Darren, otherwise known as MaffsGuru, and it's really good to see you along. If you are new to my channel, can you do me the biggest of favors? And over there's a red arrow that says something along the lines of support me. I'm a very small person trying to do a very, very big job. It's just me sitting in a room trying to record loads and loads of maths videos for Australia and the world. So your support, greatly appreciated. Like, comment, subscribe. Okay, so stem and leaf plots. As I said at the beginning just there, obviously the whole lesson's about stem and leaf plots, but it's building on the stuff we have done before. And when I say done before, videos and lessons, if you have me as a teacher, much respect. You know, we've been looking at all the different ways we can show data. Data on its own, or data on its own, is actually incredibly boring. Just lists and lists of numbers, and our brains can't really do much with those numbers. But when we start putting them into graphs or pictures or diagrams, our brain can suddenly start making links. It can make associations about which is the most popular mode, which is the average, which is the middle one, medium, and how far spread the data is apart from each other. So that's really why we do this stuff. Now, in a lot of the graphs that we do, we lose the data. So if you think back to pie charts and bar charts and whatever, we don't actually get to see the physical numbers that we recorded. And that's where stem and leaf plots come in. And they are amazing. So a lot of people go, why is it called a stem and leaf plot? And I sort of go, well, think of a tree. We have the main trunk of the tree, we have some branches, and off of that one branch comes lots and lots and lots of little leaves. That's the general idea. Now we can think of a branch as a stem, all right? So we have a stem and lots of leaves come off that one stem. Now while we might have lots of stems that may have lots of leaves, that's very much the general idea here of what a stem and leaf diagram is. Now, I could show you one and you'd be like, huh? But I think the best thing to do is actually try and draw one of these things. And as I talk about it, I'll highlight all the important features. Now, the first thing I'm going to do here is do an unsorted stem and leaf diagram. Now, can you work out what an unsorted stem and leaf diagram is? Well, obviously, I suppose the key word there is unsorted. So basically, the first thing we need to do with this type of data, and you don't need to put it in order, it's fine, is find the smallest possible number. So I think the smallest possible number here is 10. So that's very important to me. And what is my highest possible number? I think the highest it goes to is 37. Okay, 37. So what I'm now going to do is I'm going to draw a line and I'm going to create my stems. Oh, wow. No, I'm not going to draw pictures of trees. I'm going to put the numbers 1, 2, and 3. They are now called my stems. And from those sprout my leaves. And you're going to say, what on earth are you talking about? Well, let's start with the first number, 23. 23 is represented with a 3 on that side. Now, obviously, all of you out there will go, oh, I can see that. That's 23. Fair enough. Now, I'll put a circle around it, but what I actually do now is put a line through it. Why do I put a line through it? So that I know I've already counted it. Now, obviously, we've only got, I don't know, what, 10, 15 pieces of data there. If you had 100 pieces of data all over different lines, wow, our brain would fritz. And what if you double counted something? What if you missed a number? Then sadly your answer would be wrong. So by crossing them off, we know where we are and we know what we've counted. So 10 is 1 and a 0. 36 would be 3 and a 6. Do you see what I'm doing? All I'm doing is putting that last number after the line. So 25. Now where does 25 go? Well, I put a 5 there. Now that's not now 235. There is a 2, my stem, and there is a 5, my leaf, or lots of leaves. 31 goes there. 34 goes there. 34, oh, we got two 34s. Whoop, whoop. 27 goes there. 36 goes there. 37 goes there. 16, we put a 6 there. And 33, we put a 3 there. And ladies and gentlemen, there is my stem and leaf diagram. Well, sort of. It's not quite finished. Now, obviously there we've said it's an unsorted stem and leaf diagram. I get that. That's fine. But it doesn't actually tell us anything really important at this moment. The most important part of a stem and leaf diagram is actually the key. We have to tell people what the numbers stand for. And so what we do is this. We go, for example, to line 3 equals 23. Now, that might seem really obvious to you, but actually we can use these things to stand for decimal numbers as well. And funny enough, if I had the number 2.3 on a stem and leaf diagram, there would be the 2 and there would be the 3. Now, without that key, without telling people what the numbers stand for, then we could make horrible mistakes. There is a huge difference between 2.3 and 23. And ladies and gentlemen, that's pretty much it. That is my unsorted stem and leaf diagram. So what is a sorted stem and leaf diagram? Well, funny enough, we're going to take the unsorted stem and leaf diagram and we're going to put all of those leaves in order. So, hoping I've got enough room here, I'm going to do 1, 2, and 3. Obviously, they are already in order. 0 followed by 6 is already in order. Then we luckily have 3, 5 and 7. They were already in order, but moving up slightly so we can get a bit more of this on, I now have to go 1 and I'm going to put a mark through it. I'm going to put what next? 3. I'm going to put a mark through it. I've got 2 4s. I've got 2 6s. And I have a 7. And there we go, ladies and gentlemen. There is my sorted stem and leaf diagram. We are done, yes? No. Hopefully you were shouting, no, 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 you've forgotten the key. I haven't forgotten. And again, we would write the key. We'd say the key is that 2 line 5 equals 25. Now you're going to say, hold on a moment, earlier you used 2 line 3. I can choose any number I like. In fact, the number I choose doesn't even have to be a number in my stem and leaf diagram. I just need to tell people the difference between, is it 23 or is it 2.3? Okay, now if this was heights, for example, we would actually put centimeters as well. If I was measuring people's heights, and that's a very short person, maybe these are heights of babies, we would write the centimeters as well to give them an indication of the unit. But this question doesn't have anything. Now, some of the questions I get asked is, well, what about if we've got numbers with hundreds in them, like 103, 105? Well, 103, 105, 123, 140. Let's do those numbers there. Now, actually, the leaves are always the last number. So if I look at 103, I do my leaf such that that 3 is on its own. What about 105? Again, that's where my leaf is. 123, 3 is my leaf. And 140, 0 is my leaf. And if I was to try and then draw that, I would have 10, 11, 12, 13, and 14. Now, a lot of you can say, well, hold on a moment. There were no 110, 111 numbers. There were no 130s. No, but you have to put them in. You have to put those numbers in. As soon as you start counting from your lowest number to your highest number, you must put those middle bits in. So we would have 3 and 5 for 103, 105, 123 would go there, and 140. So you see what I mean? Even if we had thousands, if I had 1,234, my leaf would be that 4. Understand what I'm doing? Awesome. Now, obviously, as I say here, the most important thing here is to make sure you have a key. Don't forget the key. Every single mark scheme in maths gives 1 mark for the key of your stem and leaf diagram, or in fact, may take all of your marks away if you don't put a key in. Ooh, that would not be good. So obviously here we have an example taken from the Cambridge Essentials textbook series, and thumbs up to Cambridge for allowing me to use their examples in these videos. Greatly appreciated. Hopefully I'm doing you proud. So we have a really bad screenshot. I don't know what I was thinking about there. Obviously there was some sort of pop-up box, but ignoring that completely, average daily temperatures, so we know it's temperatures, are shown for some different countries. We have a stem here, we have a leaf here, and obviously, what do we have? We have the most important thing here. We have the key. Thank you very much. So the question now says, rather randomly, write out the temperatures of the list. The reason it's asking you to do that is to see whether you understand how to read and stem and leaf diagram. It's all well and good drawing them, but you have to be able to understand them as well. So, writing those numbers out, we would have 13 and 16 and 16. So that's the 1 and the 3, 13, 1 and the 6, 16, 1 and the 6, 16. Then we'd have 20 twice, 21, 22, 25, 25, 26, 28 and 29 and 30 and 32. Whew, that was challenging. Just checking I've got the right number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. it's always important to do a check because, again, in a moment, if you're being asked to find the median, if you're being asked to find the mean and you've missed a number, you're going to get it all wrong. Your calculation might be perfectly right. The maths behind it might be right. But if you've stuffed up by missing a number, bad news. So we've done A. That was easy. We got a mark for that. How many countries' temperatures are represented? Well, we just counted them. I think I said there was 14. 2, 4, 6, 8, 10, 12, 14. So nice and easy. They're just asking you how many numbers were in that stem and leaf diagram. Tick, 1 mark. What are the minimum and maximum temperatures? Now, life was easy here. We actually, because we wrote them out, we could see very quickly that my minimum was equal to 13 degrees and my maximum was 32 degrees. But the great thing is here, don't worry about it. We could still have read them off from the lowest number on my stem and leaf diagram or plot to the highest number. Tick, thank you very much. What is the range? Wow, this stuff's not complicated, is it? Because we know the range is the highest number. Take away the lowest number. So my range is equal to 32 minus 13, which I believe is 19 degrees. No, yes it is. It's 19 degrees. Thought for a moment I'd made a mistake. And what is the median temperature? Now, I think this was the hardest part of the whole question. You know, lots of easy marks here. How do we find the median? Median sounds like medium, and medium's in the middle, so we're looking for the middle number. So cross 2 off the front, 2 off the end, 2 off the front, 2 off the end, 2 off the front, 2 off the end, and loeth and behold, we have 2 middle numbers. We can't give 2 middle numbers. The median has to be an actual number. And do you remember how to find the middle of 2 numbers? I should, Coco. We add them together. So my median is equal to 22 plus 25 and then divide them by 2. So that would give me 47 divided by 2, which gives me a wonderful 23.5 degrees as my median. Again, not overly complicated. These things are flipping awesome. I was going to say awful, but I meant awesome. Now, things to remember, because again, you could be asked, when do you use a stem and leaf diagram? Well, obviously we use stem and leaf diagrams for numerical data. We can't put categories in. Why can't we put categories in? Because you cannot put categories in an order. We can't say that blue eyes are more important than brown eyes, which are more important than green eyes, which are more important than red eyes. Nah, order, we can't do that. So it's only numerical, yes? The numbers are called stems and leaves. We need to know that. A key must be shown. And an outlier should be identified. Again, what's an outlier? That's a number that sits way, way, way outside of our data. So for example, if I had a stem and leaf diagram of 2, 3, 4, 5, 6, 7, 8, 9, and we had lots of numbers here and here, and then one number out here on its own, that would be an outlier. Now, one big thing to note about stem and leaf diagrams, and before I get to Barry trying to trick us, what do you notice about how the numbers are written? They're written in beautiful columns underneath each other. Later on in maths in year 8, 9 and 10, the fact that they're written in columns and the beautiful shape we can see actually becomes really important to us. So don't just write these things randomly across. We have to do it. Now, can you see the trick that Barry's trying to do here? We dealt with a stem and leaf diagram with one stem and leaves coming out, but it would appear we have a stem in the middle and leaves going both sides. Now, why, oh, why do you think that is? Well, because as usual, Barry has sat there and said, I'm going to try and trick you with a very simple trick. And stem and leaf diagrams can actually hold 2 sets of information. It doesn't have to hold one. We can actually compare data. So what do we notice here? We have boys and girls. Ja, boys and girls. Unser stem. Ja, very gut. Do we see our key? Yes, we see our key. And in this situation, they've put the centimeters because we're obviously dealing with the heights of boys and girls. And again, what is our lowest height for boys? How would we find the lowest height for boys? Well, that's the first number in the boys. That's its leaf. It's by the stem of 138. So the lowest height for the boys is 138. And the highest? 168. What about for the girls? What's the lowest height for the girls? Well, it is not 612. That would be nuts. Could you imagine a 612 centimeter girl? That's 3 times higher than your average classroom door. I don't think that child would not be in a school. Unfortunately, it would probably be in some sort of research facility. So we have to make sure that this one here, we read properly. So here's my stem, 1, 2, and my lowest number is actually 1, not the 6, it's the 1. Oh, Barry. Ooh, you are not a nice man. And what about the highest? Well, again, it's not 317. it's 173. So make sure you know how to do this. Now again, in maths, what we do forwards, we have to be able to do backwards. And this tests your understanding of the work. Now what do I mean by that? Well, if we understand what a stem and leaf diagram is, we can take certain numbers out, hide them with letters and say to you, well, what do you think that letter could stand for? Oh my goodness, algebra meets statistics, bum, bum, bum. So let's look at this one here. Let's zoom in a little bit, yeah? We have a stem and leaf table where we've got A, B, C, and D. So they've taken those numbers out, and what all they're saying to you is, can you give us a good idea of what that number could be? Well, the first one I'm going to deal with here is A. And what do you notice? Well, it's between the 5 and the 6. Now, no, do not say it's 5.5. Because remember, the leaves have to take whole number values. We didn't write decimals in there. No, have to take whole number values. So what is between 5 and 6? Well, funnily enough, 5 or 6. Because remember, we could have written this as 2, 4, 5, 5, 6, 7, 9. So that's my A. Or we could have written that as a 6. It couldn't have been a 7. It couldn't have been an 8. It couldn't have been a 3. Why not? Because these have been written in order. And so the number A, or the numbers that A represents, have to be either 5 or 6. So there are two answers for what A could be. So using the same information, what could B be? B. Well, it's actually on the left-hand side of that 0. And what number is lower than 0 or equal to 0? Well, actually, 0. So the only number B could be is 0. No, it can't be a negative number. I don't know that stem and leaf diagrams can show negative numbers. I certainly have never used them to show negative numbers. So what about the value C? Well, it's on the right-hand side of 8, so it could be 8 or 9. Spot on, 8 or 9. And what could the value D be? Well, actually, it could be anything. 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And ladies and gentlemen, the excitement of stem and leaf diagrams is done. Allow me to move to the other side of my screen. Hi, I'm back. Welcome. And now I'm going to grow bigger because, as I say, this is the end of the lesson. Hopefully you know everything now you need to know about stem and leaf diagrams. Thank you so much for watching. It's always a pleasure seeing you here now. If you could do me a massive favor, over on the other side of the screen is a circle that says subscribe. If you haven't already subscribed, please do so. And if actually you know friends who haven't subscribed, get them to subscribe as well. Hopefully they will enjoy these lessons and videos. Otherwise, there's a video below it showing. This is MaffsGuru wishing you a wonderful day. I look forward to seeing you next time. Bye-bye.